what we are sure is that we must have a question on photoelectric effect in A-level physics 9702 in 2026. So if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. So we're going to look at different questions that have been asked in previous years and most recent years as far as photoelectric effect is concerned. So let's dive in so that we can be able to get started, so that we can be able to see how do you answer questions as far as photoelectric effect is concerned. So here we're going to talk about de Broglie wavelength. You may be asked question to do with de Broglie wavelength in terms of definition. Remember, electrons can behave as waves are the same, can behave like particles. So in this case, we're going to define de Broglie wavelength as a type of wavelength which is associated with moving particles. And in this case, you need to remember that de Broglie wavelength is calculated by the formula lambda, which is de Broglie wavelength is equals to Planck's constant divided by the momentum of the particles which are moving in that case. So if we are given the speed of electrons to be 4.9 times 10 raised to the power 7, we are going to say that is Planck's constant of the mass of the electron, which is 9.11 times 10 raised to the power negative 31, times the speed at which those particles are moving, so that we can be able to get the de Broglie wavelength. So another question that you can be asked also is the question to do with differences between a positron and electron. You need to understand that these are antiparticles. A positron is an antiparticle of an electron, so they have the same mass, they have the same magnitude of charge, but they have opposite on an electron has an opposite charge to an electron. So here we are going also to really have to, so here we are going to look at the differences which we have mentioned, that they have the same amount of mass, same magnitude of charge, but they have opposite signs. So let's dive in so that we can be able to see more questions that were asked in this area. You can see here we are told to explain. Let me just move a little bit this so that we can be able to see. Yeah, we are supposed to name the type of reaction whereby when an electron and a positron fuse together, they disappear. That type of reaction is called pair annihilation. When an electron and a positron react, they are going to disappear, and then we are going to see two photons being emitted, moving in opposite direction, and that is pair annihilation. And the reason as to why, what happened to these electrons and what happened to this electron positron, they fuse together and then their mass is converted to energy. So that is why we're going to see that they are not going to be seen anywhere. Their mass is converted to energy of the photon. Explain why two gamma photons are produced. Here you're going to say two photons have to be produced so that whenever they are going to move in opposite direction, they are going to conserve momentum, so that momentum is going to be conserved. Show that the kinetic energy of the electron before collision is that. So we were given the speed at which the electron were moving, and remember, if a particle is moving, it has what we call kinetic energy, right? So meaning we're going to use kinetic energy equals to half mv squared. So meaning that we're going to use the mass of the electron, which is 9.11 times 10 raised to the power negative 31. Then the speed at which they were really moving, because we were given the speed. So if you can be able to work out the kinetic energy, you realize that the kinetic energy here is going to be 1.1 times 10 raised to the power 15. Use the information in D Roman 4 to determine to three significant figures the wavelength associated to this movement, to the gamma radiation emitted. And remember, the energy of the electron, the kinetic energy of the electron is 1.1 times 10 raised to the power 15. But this moving electron, what you need to have in mind, so when these two, so this becomes the energy of the kinetic energy of the particle electrons. Now moving to Roman 4, we are told using the information in D Roman 4 to determine to three significant figures the wavelength associated with the gamma radiation. Remember, the gamma radiation will be having the kinetic energy of the electrons. At the same time, the mass of the electrons will be converted to energy. And the mass of the electron was 9.11 times 10 to the power 13, but the speed at which the electron, now we're going to use mc squared, the mass of the electrons times the speed of light. So if we add the kinetic energy plus the mc squared of the electron, then we're going to get the total energy of the photon to be 8.31 times 10 raised to the power negative 14. Then we are going now to say that that photon has the energy hc over lambda. So the energy that we have gotten, which is 8.31 times 10 raised to the power negative 14, should be equals to lambda's lambda's constant, lambda Planck's constant, which is going to be equal to Planck's constant, that is speed of light, over lambda. So if you substitute there, you are going to get your answer as shown here. Moving further now, we are told a laser emit light of let me just move this a little bit. State what's meant by a photon. You need to know the definition of a photon as if you are going to do this exam, because we need to define a photon as a quantum or a packet of energy of an electromagnetic radiation. In quantum physics, energy flows in packets. Energy flows in discrete amounts. Energy flows in quantums. So that's why we have to define a photon as a quantum of energy of an electromagnetic radiation. Now here, part B, we are told the laser emit of light of a single wavelength. Light is produced when an electron moves from higher energy level to a lower energy level. And the difference in energy between the two energy levels is 1.96 electron volts. So we are supposed to convert this energy, calculate the wavelength of energy. So energy is equals to hc over lambda. And then if we make lambda the subject, the formula, we are going to have our answer as 3.2 times 10 raised to the power 16 meters. But something that you need to remember, the E that we have at this lower point that we're going to actually so the energy that the E that we are going to have at this point here must be converted to joules, because 1 electron volt is basically equals to 1.6 times 10 raised to the power negative 19. So that we have to put it in mind as we are working it out. So this is exactly what we are supposed to get. Now determine the average force exerted. So in that case, we are going to use this formula. Momentum is equals to energy over the speed of light. So that once we have the momentum now, we can be able to go ahead and work out. We are going to say now, change in momentum is equals to a half p, and this is a half of those electrons which are absorbed, and change in momentum for those change in momentum for those electrons which have been reflected will be twice. So we are going to have 3 over 2p. So in our case, change in momentum will be equivalent to that. But now force will be number of the electrons times the change in momentum which we have gotten in the previous section. And remember, force is equals to change in momentum over time. But in our case, time is 1 second, so there's no need for us really to write that. Then since we had gotten the number of electrons from the previous section, we can be able to substitute the values so that we can be able to calculate the force, because we had gotten the number of electrons from the previous part. And then 2 over 3 times the change in momentum, or the momentum that we had gotten. Then if we work it out, we are going to get our answer equivalent to 5.0 times 10 raised power 11 newtons as the average force that is exerted. So what you needed to remember in this particular question is a few things, a few concepts here. Number one, change in momentum for those electrons which are absorbed, it will be a half p, because we were told a half of the electrons were absorbed and a half were reflected. Then for those that are reflected, the change in momentum will be a half, 2 times the momentum. So we are done on that part. Next question is you need to define the definition, or you need to give the definition of a photon. We have said is the quantum of energy of an electromagnetic radiation. Moving further, we have a question that is asking us to, from this graph, what is this phenomenon where electrons are emitted from metal surface? This is going to be photoelectric effect. So if you are asked a question like that, we need also to use the graph to determine or to make different conclusions. From the graph, we can be able to notice that the threshold frequency is 5.4 times 10 raised power 14 hertz, which you can be able to see where the graph is cutting the x-axis. The work function can be also be determined from the graph, and this is determined from HF F naught, because already from the graph we read photoelectric effect, the threshold frequency is 5.4 times 10 raised power 14. Then it means we can be able to use that to work out the work function, and if you work it out, it's going to be approximately that value that we had mentioned. The third concept that we're going to say is that Planck's constant can be obtained from the gradient of the graph. And in this case, you are not going to state 6.63. You will state Planck's constant based on the graph. So basically, that's what you are to say in that particular question. If you are new to Prof Learn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. In Prof Learn YouTube channel, I do maths and physics. So if you are new here, consider subscribing so that when I'll be uploading further tutorials, you'll be notified. So next we are told in experiment B, the experiment in B is repeated twice, each time making one change, and state with the reason how the graphs obtained will compare with figures 7.1. Now we are doing the experiment at different metal. Then meaning that if a different metal is used, we are going to have a different value of threshold frequency, because different metals have different threshold frequency or different work function, because you require different amount of energy to eject an electron from the metal surface. So that's what we're going to say. But in this case here, we are told that intensity is going to be double, but everything is going to remain because the graph is going to remain the same, because even though the intensity does not affect the graph. Moving to the next question, let's see which question you really need also to prepare. Let's move and see those questions that we have not done so far. Now, we need to also understand the definition of photoelectric effect. What is photoelectric effect? What is work function? In that case, this is the emission of photoelectrons from a metal surface when an electromagnetic radiation is incident to a metal surface. So suppose you're given a question like that, you need to be in a position to define photoelectric effect. So if there is a radiation directed to a metal surface, we're going to see an electron being ejected from the metal surface. And something also that you need to remember in such a case is that for photoelectric to take place, the radiation must have the minimum amount of frequency so that it can be able to eject. And this amount of energy that is minimum for an electron to be ejected is called the work function. Now, defining a work function is the minimum amount of energy required for an electron to be ejected from the metal surface. Now, we need to move to the next part, whereby we're told that a polished calcium plate in a vacuum is investigated by illuminating the surface with light. It's found that no photoelectric current is produced when the frequency of light is less than 6.93. Then we are supposed to name the state the name of the frequency below. No photoelectric effect is going to be emitted. And this is the one that we have said now. This is called threshold frequency. This is called threshold frequency. Explain how the photon model of electromagnetic radiation account for this phenomenon. We are going to identify and say that photoelectrons are these discrete packets of energy, and we know that the energy of a photon depends on the frequency of the electromagnetic radiation. And also we need to note that every electron interact with can only absorb only one photon. The photon interact with only one electron. So if the energy is not sufficient to eject, then it will not be absorbed. Then we're supposed to calculate the work function in this question here in electron volts. Here we were given 6.93 as the threshold frequency, so we know that energy is equals to work function is equals to hf naught, and then we are going to use Planck's constant there. But remember, we are going to give our answer in electron volts. It means we're going to divide by 1.6 times 10 to the power negative 19. And if you work it out, you get your final answer being equivalent to 2.87 electron volts. And if you are new here, consider subscribing so that in time we're going to upload more tutorials, you'll be notified. See you in the next tutorial.